students. In this session, we will learn about electric flux. To understand electric flux, you think of an area. This area is vertical. How will you draw normal to that vertical plane? Normal will be always perpendicular. This is the normal to that plane. You can think of an A4 size paper held vertically in this case. If the plane is horizontal, this is the horizontal plane and the normal is this one, which is perpendicular to that plane. If the plane is tilted slightly as in this diagram, the perpendicular or the normal will be like this. Normal will be always perpendicular to the plane. We have already learned electric field and we know the electric lines of force. In figure A, these are the electric lines of force. And these electric lines of force are passing through this area. This area or plane is held vertically so that it is perpendicular. Electric flux is the number of lines passing through that area normally. In figure B, these are the lines of force. These lines of force and the area, this is the area or the plane, and this area is parallel to that electric field. In this case, the normal will be like this. The electric lines of force are passing in this way. Therefore, the flux will be 0. Flux is the number of lines passing normally. Here it is maximum, whereas here it is 0. Electric flux is the amount of the number of lines, this amount that is passing through this area. The area vector is shown here. This is the area vector and the lines of force are passing normally, and this amount or the number of lines of force passing normally is called as electric flux. It is represented using the symbol phi. Phi E indicates electric flux. This is E dot A. Electric flux is equal to this E and this is the A. E dot A. E is a vector quantity. A is also a vector quantity. But phi is a scalar quantity. E dot A means it is a dot product. What is dot product? Dot product is EA cos theta. In this case, the area is horizontal. This is the area vector normal to that area. The lines of force are passing horizontally. Therefore, the theta, what is theta angle? Theta is equal to 90 degree, cos 90, 0. Flux will be 0. In this case, it is tilted slightly and this is the area vector and this is the normal and this is the angle theta. The phi will be EA cos theta. If the surface is curved or if electric field is not uniform, then how will you find out the electric flux? In such cases, you will consider a small element from that surface. For example, in this diagram A, the surface is curved, as you can see, and the electric lines of force are not uniform. Here in this diagram also, these are the lines of force which is not uniform, and this is the surface which is not plane. In such cases, you will take a small element from that surface. Here it is DA. You will use the letter DA to represent that small element. If you take a small element, then it is easy to draw that normal to that small element. In this diagram, this is the small element you are considering, this one. The electric flux linked with a surface in an electric field may be defined as the surface integral of the electric field over that surface. In the curved surfaces, or if the field is not uniform, we took small element dA, isn't it? Then we need to integrate that element. This sign indicates closed integral because the surface is closed. Flux phi is equal to E dot A. That is what we learned. Here, when we consider the small element, you will put dA. That's all. E dot dA. And you need to integrate this. Closed integral of E dot dA will give you the electric flux. We learned electric flux. Electric flux means the rate of flow of electric field through a given area. Phi E is equal to, this is closed integral E dot dA. Area element is a vector quantity. What is dot product of E dot dA? E dA cos theta. Always remember, dot product will be cos. E dot A means EA cos theta. Phi E is equal to closed integral E dot dA. E dot dA is EDA cos theta. In this place, now we are going to substitute this value EDA cos theta. Therefore, phi E becomes, in this EDA cos theta, take E cos theta outside, integral dA. What is integral dA? Integral dA is A. Now you can substitute in this place A. E A cos theta. Always remember, phi E is equal to EA cos theta. Now let us define electric flux. Electric flux through a surface held inside an electric field represents the total number of electric lines of force crossing the surface in a direction normal to the surface, denoted by phi E. Phi E is E dot A, or closed integral of E dot dA. It is EA cos theta and it is a scalar quantity. What is the SI unit of electric flux phi E? SI unit is, or electric field is Newton per Coulomb. Area unit is meter squared. Therefore, unit is Newton meter squared per Coulomb. This is the unit of electric flux. In this session, we learned about electric flux. Electric flux is the number of lines of force passing through a given area. It is represented using the symbol phi. Phi E is equal to, phi E means electric flux. Phi E is equal to E dot A. If you are considering a small element dA, then you need to integrate. This is the closed integral E dot dA. Dot product is always scalar. Dot product is cos theta. Therefore, E phi E is equal to EA cos theta. Dot product is otherwise known as scalar product. Hence, phi is a scalar quantity. Electric field E is explained in my previous video. Please watch that video before studying electric flux. I hope you understood electric flux. See you in the next class.